No. You're thinking symmetric property when it's swapped. Reflexive property. When you look in the mirror, you see your reflection, so you're seeing yourself. So it could be, right, so line segment AB is congruent to line segment AB. Or it could just be the length of AB is equal to the length of AB. Okay, we are not, no, not in this chapter. We are not going to have any reflexive properties with angles. So we'll just stick to our segments here. Symmetric property, what does that look like? That's when it's flipped, right? So if AB is equal to CD, then CD equals AB. And the only reason why we would use that is if we ended up with something on the bottom of our proof and we needed to re-flip it to make it look like the proof line. We're not going to be using symmetric property in Chapter 4. We're honestly only going to be using the reflexive property. We put a big star next to that one. That's the only one we really are going to care about. Transitive property. If AB is equal to CD and CD is equal to EF, what does the transitive property tell us? Good. Take out the middle, so then we're left with AB is equal to EF. Good. Again, reflexive property is the biggest one that's going to be used in Chapter 4. All right, so now let's make a quick note of what's on our blue sheets of paper. If you do not have the following, make sure you do. This is not in your notes, so you should just be looking at your blue sheet of paper. Do you, on your sheet of paper, have some statement about a midpoint?
H is a midpoint of
Good. So you should hopefully, if you do not, get it on there. If a midpoint, then you end up with two congruent segments. If that's not on your blue sheet of paper, you're going to want to put it on there. So check to make sure it is on there. Do you have on your blue sheet of paper anything about a bisector? What do you have? Good. If angle is bisected, then two congruent angles, and then you probably have the same thing for segment. If a segment is bisected, then two congruent segments. Make sure those two are on your blue sheet of paper. If they're not, make sure you add them. Okay. What else do we have? Do you have anything about perpendicular?
If perpendicular, intersect at 90-degree angle.
Then intersect at 90-degree angles. Good. Make sure that's on there if it's not. What's true about 90-degree angles? Yeah, so if you have right angles, isn't it true? You might not have this on here. So if you have right angles, then isn't it true that they're congruent? This right angle is not congruent to that right angle? Would all right angles be congruent? Because they all have the same measure. Right angles are 90 degrees, right? Okay, so if we know what it means to be bisected and we know what it means to be perpendicular, we're going to add a new statement. What if I combine it together and say, if perpendicular bisector? What do you think that looks like? So here I have a triangle. I'm going to put in line segment AD and call that a perpendicular bisector. What does that mean? What do I end up with because of it being perpendicular? I'm going to end up with 2 right angles, right? And because it's bisecting, what else am I going to end up with? Where are my congruent segments going to be? Here and here, right? So depending on what you need out of the proof, if you end up with a perpendicular bisector, you can go 2 ways. You could do then, you get right angles, or then you get 2 congruent segments. So if you see perpendicular bisector in a given, and we'll eventually get there, probably not today. What's nice is you can either pull the fact that it's a bisector, and what do we know about bisectors? They give us 2 congruent segments. Or you can pull the fact that it's perpendicular. What do we know about perpendicular? They create right angles. Or maybe you want to use both those aspects. Okay? Do you have your parallel lines information? If parallel, then all that fun stuff? Yep. So if parallel lines, then alternate interior angles are congruent. Make sure that's not in there. If parallel, then alt interior angles are congruent. If parallel, what's true about alternate exterior? Good. Exterior angles congruent. What's true about corresponding? You're thinking consecutive interior. Yeah, so if parallel, then corresponding angles congruent. And then consecutive interior means they're supplementary. We're not going to use those in chapter 4 because we're going to be looking for congruent angles. Make sure those are on your blue sheet. Are they on your blue sheet? Okay, good. So now we should be good to go with proofs. So let's jump back to our notes. We're going to add an actual proof to our notes too. We're going to do 2 and then add a third. So here's our first proof. They're giving us that line segment HF is congruent to line segment HJ, FG is congruent to JK, H is the midpoint of GK. And we want to prove that the 2 triangles are congruent. So where do we always start? The given. So line 1, take some time right now to recopy the given. So line segment HF is congruent to line segment HJ. Line segment FG is congruent to line segment JK. And we're given that H is the midpoint.
Wait, where's J?
Oh, I think, where is J? Good point. FGH.
Is that supposed to be the
I think it's supposed to be a J up there at the I, yeah. Thanks, Camille. Midpoint of GK. Given. You guys have this? Okay, so now, this is what I personally do when I am given any of these proofs to prove that triangles are congruent. The first thing I do is I'll mark whatever is given to me in the diagram, which in the diagram is already given to us. So notice they put tick marks on HF and they put tick marks on HJ. That means they're congruent. They put tick marks on FG and JK because those are congruent. Okay? So the first thing you should do is mark the diagram to try and get your train of thought going. Now, you are only doing proofs today on side, side, side. That means somewhere in your proof, you need to have 1, 2, 3 sets of congruent corresponding sides. So what I personally do is off to the side, I work off of the congruent statement in the proof line and just list my corresponding parts. Now, because today we're only doing side, 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 I'm only going to do the 3 sets of sides.
How can we find out that JK?
Hold on. Pause for a second. So I'm given FG. So off to the side, I'm going to put FG needs to be shown congruent to JK. Then I'm going to do the last 2. GH Sam, should match up with what?
HK.
Well, GH would be KH, and then FH would match up with JH. Good. So I just do this for my own benefit. Because in order to say that these are congruent, I need to have these three statements listed under my statement. Well, which ones were given to me? Well, the first one was HF and HJ, which is the last one. So I'm going to put a little check mark next to that one, because that one's already given. We were also given FG and JK, so I'm going to put a little check mark there. So what else do I need in my proof? Now, Owen, here's the trick. If you do this, then you know in your head, I need to have that in my statements for my proof. If you want to get half credit for the proof, throw it in there.
But we're not gonna, we want full.
We want full credit, so that means we need to then back it up with the reasoning.
Can we just like throw that one like in the given section?
Well, don't throw it in the given, make it line 2.
One in there, or does it have to be like logically?
It has to be line 2.
Oh.
So let's put it in there. So line segment GH is congruent to line segment KH. And I'm only throwing it in there right now because I know Mrs. Crowley said I needed to have 1, 2, 3 sets of congruent corresponding sides. Well, we have to back that up with some type of justification. So this is where our blue sheet comes into play. Look at the given. Do you see any key word in the given? I see the word midpoint. So then I would go to my blue sheet, scroll through until I found a statement that said the word midpoint in it. And what does it say? So let's make sure this makes sense. If H is the midpoint of GK, does it make sense that GH and KH would be the congruent parts? Yeah, right? So I'm going to put that under my reason. So line 2, if midpoint, then 2 congruent segments. Would you be able to do that? So now do I have 3 sets of congruent corresponding parts checked off in my statements? So now, since I have 3 congruent corresponding parts, I can then say that my triangles are congruent. So line 3, I'm going to rewrite that prove line. Triangle FGH is congruent to triangle JKH. And here's the beauty. What postulate are we talking about in section 4.3? Side, side, side. Because what does the side, side, side congruence postulate say? If you have 3 sets of congruent corresponding sides shown congruent, then it must be true that the triangles are congruent. So all I need to write over here is SSS, and you must attach the congruent symbol to it, because there is a different one when we get further. You can.
I thought you said we had to use FN.
For these, I'm going to let you just write the abbreviations of them. Okay? So we've got side, side, side congruence. So whenever you have your final statement, and just for today, because this is the only one we have, Nate, you want to flip that over, please? All of your proofs will end with side, side, side. And match it up with your triangles. Okay, flip on the back. Let's do the next one. Go ahead and set up your T-chart, because it's not there for you. Statements on the left, reasons on the right. Always, always, always start with your given. So we were given line segment GH is congruent to line segment JK. We are given line segment HJ is congruent to line segment KG. All right. Now let's just get in the habit of listing out my corresponding parts. Because once we get all 5 of the shortcuts, if you list it, it'll kind of help with your thought process of where you're supposed to go. Even though today it's pretty easy because we only have one method that we've learned. So working off of the triangle congruence statement, I'm going to list my 3 sides. So I need GH to be matched up with JK. I need HJ to be matched up with KG. And I need GJ to be matched up with JG. Okay. Which ones are given to us? So the first is given to us, and the second is given to us. So in order to prove that my triangle is congruent, I just need one more line. What should line 2 say under the statements? Line 2 of statements should just be GJ is congruent to JG. Good.
That's symmetry.
Not quite, but you're on the right track of thinking. It is a property. Which property is it? Nope. Nope. This is the reflexive. If you look at the diagram, notice that those 2 triangles share a side. It just so happens that they are flipped. So the reflexive property still works here, even though this is not exactly the same. They are the same segment. Okay? So that's the reflexive property. And whenever you see triangles that are sharing a same side as such, it should be a red flag saying, use the reflexive property, use the reflexive property. Okay, we're going to do one more. You should have plenty of space below. We're going to add another proof.
That's all we gotta do right there?
Yep. Oh, no, we're not done. Sorry. That isn't it. What should I finish with?
The end.
Yeah, so triangle GHJ is congruent to triangle JKG because of side, side, side congruence. All right, we're going to add a proof. It's not on there, so you're going to have to make this diagram yourself and write it out, the given yourself. Wherever you have space on your notes, put the following diagram. Is everybody ready? Okay. So make that diagram ABC and DBE. If you wanted to start filling in the given in your proof, feel free.
There's no tick marks.
Well, so we can add them in because they give us one set, right? All right, I want to jump ahead of people. Okay, so Kyle noticed that there were no tick marks in our diagram, so we can add in the tick marks. So what do they give us? They give us AC is congruent to ED. So I'm going to put a little tick mark over there. All right. Now I'm going to do my little list just to help organize my thoughts. So working off of the congruence statement, I need to show AC is congruent to ED. I need to show CB is congruent to DB. And I need to show AB congruent to EB. So they gave us AC and ED. So I'm going to put a check mark next to that. They only gave us one. That means I need to get two more in my proof. So statement number 2 should say what? Sure. So statement number 2, I was just working down the line. So CB is congruent to DB. All right, well now let's look at the given. What keyword do you see? Midpoint. What do we know about a midpoint? Yeah, so if B is the midpoint of CD, then isn't it true that CB is congruent to DB? Yeah, so my reason for that is if midpoint, then two congruent segments. What should line 3 be?
The same thing, but
With AB and EB. Good. So line 3, AB needs to be shown congruent to EB. Same thing, so you can either rewrite it or just do ditto marks. That's up to you on how lazy you want to be. Personally, I'm going lazy. So now do you have all 3 sets of your congruent sides in your statements?
Oh, you could turn it into the
Yep.
transitive property.
No, because there's no connections. Like there's none of these letters here or here, so it wouldn't work. So now you have all 3 sets of congruent corresponding parts. So your last line will be your prove line. So because all 3 of those corresponding sides are congruent to each other, then triangle ACB must be congruent to triangle EDB because of side, side, side congruence. Okay. What would have changed in this proof if instead of midpoint, it would have said B bisects the 2 segments? Would anything over here have changed besides this word saying B is a bisector of these 2? Nope. What would have changed over here? Instead of this statement, we would have wrote, yeah, if a segment bisector, then it creates 2 congruent segments. Ditto mark, side, side, side. Okay, so you got to pay close attention to the keywords here because that's going to determine what this needs to be. Your statements should end up being these corresponding parts. So get them in there. Get half credit at a minimum.